For decades, scientists have advanced the evolutionary theory of origins. Of an Earth that formed by slow cooling of molten mass over 4.5 billion years to make the foundation rocks of the continents, the granites. Of life that began spontaneously in some primeval sea and then evolved over hundreds of millions of years to produce the many life forms we see on the Earth today. Of the eons-long formation and drying up of these primeval seas to produce sedimentary rocks such as in the Grand Canyon, with the canyon itself carved by the Colorado River over millions of years. Of coal and oil deposits, buried in sedimentary rocks around the world, which presumably required millions upon millions of years to form from the accumulation and decomposition of vegetation existing in ages past. But have scientists considered all the evidence in arriving at their theory of an anciently evolving Earth? What if there was evidence in the granites themselves that showed they formed rapidly instead of by slow cooling? What if there was evidence that these sedimentary formations composing the Grand Canyon were deposited quickly instead of slowly? What if there was evidence the canyon itself was carved over a short time by rapid erosional processes? What if there was evidence revealing that coal and oil can form rapidly and did so recently? What if there was evidence that dinosaurs existed not millions of years ago, but just a few thousand years ago? And what if it was found that natural laws, the glue which holds the evolutionary framework together, cannot explain everything in Earth history? We would then be forced to consider another model of Earth history, one that would acknowledge the possibility that geological rates of change in the past were much greater than those observed today. In this scenario, it would take much less time for various geological events to occur. We would then have all the ingredients for concluding that the Earth is actually quite young. But is there any published scientific evidence which challenges the evolutionary view of an ancient Earth and supports a young Earth? Scientist Dr. Robert Gentry, while working at the Oak Ridge National Laboratory in Tennessee, has found just that, publishing evidence which challenges the long time period of Earth's history. In 1977, the Research Communications Network published a special breakthrough report on the results of Dr. Gentry's scientific publications, characterizing their implications as follows. Current physical laws may not have governed the past. Earth's primordial crustal rocks, rather than cooling and solidifying over millions of years, crystallized almost instantaneously. Some geological formations thought to be 100 million years old are in reality only several thousand years old. Grant these propositions and any researcher will tell you the entire structure of the historical natural sciences would dissolve into formlessness. Few certainties would remain. Yet these very possibilities, and others equally challenging, have been suggested in a remarkable series of papers published over the past several years in the world's foremost scientific journals, Nature, Science, and Annual Review of Nuclear Science, among others. From Research Communications Network, Breakthrough Report 1977. Part of Dr. Gentry's work referred to in this quote pertained to his work with coalified wood from what is known as the Colorado Plateau, a broad geographical region encompassing parts of Colorado, Utah, Arizona, and New Mexico. Using the microscope and more advanced laboratory equipment, he analyzed these specimens of coalified wood for various types of radioactivity. His results help us to understand how long it takes coal to form, the age of the coal, and the age of the Earth itself.
what averse vast energy resources. Before we can answer the question as to the age of coal and the time of its formation, we need to ask the question, where did coal come from? Here in this coal mine in Price, Utah, we have the answer. Here is a log, almost completely turned to coal. There are thousands of such logs in this mine and in other mines here in the Price area. This fact tells us that given the right conditions of pressure and temperature and water and time, that wood and other vegetation will turn to coal. The question is, how long did it take for that to happen?
Robert Gentry and his son David, an associate in his father's work, explore this topic together.
To answer this question, we need to look at coalified wood specimens from uranium mines instead of coalified wood, like this log, from one of the coal mines here in the Price, Utah area. This coalified wood specimen comes from La Salle, Utah, a uranium mine. Its presumed geologic age is around 140 million years.
This specimen of coalified wood comes from a uranium mine in the Temple Mountain area here in Utah. Its presumed age is also 140 million years. But look how closely this specimen resembles this other piece of wood. They're nearly identical. It's interesting to note that this other piece of wood was derived from a fresh piece of wood like this, just a few weeks ago.
This close similarity raises an important question. Is it really true that this piece of coalified wood from La Salle, Utah, and this piece of coalified wood from Temple Mountain, Utah, are really 140 million years older than this piece of wood, which David and I recently obtained in some of our experiments? Not really. Locked in these and other coalified wood specimens from uranium mines is some remarkable evidence that tells quite a different story. To see that evidence requires that the coalified wood specimens be mounted in epoxy, thinly sliced, and then placed on glass slides for observation under the microscope. Under the microscope can be seen discolorations produced by radioactive particles ejected from tiny centers. Some are circular, others are elliptical, as can be seen in these photographs. These circular and elliptical halos required a special sequence of events to form, so special, in fact, that they completely overthrow the idea of an ancient age of coal, pointing instead to coal's recent formation